My name is George Small, the Moog's Chief Technology Officer. Today I'm going to talk to you about safe human-robot collaboration in construction. So just a couple of words on myself. Let's see, I grew up in the Buffalo, New York area in the United States, went to university locally as a mechanical engineer, started at the company Moog in 1996 as a design engineer in flight controls, eventually ended up becoming chief engineer for that group in 2007. And then I've moved into a role as chief technology officer for the company in 2017. Along that path, I became engaged in this robotics community back in the 2000s when at the time it was exoskeletons. Moog had gotten involved because of our motion control background in a number of research projects. It was kind of my introduction to mobile robotics. That eventually led to a connection and a collaboration with Claudio Cimini and his group. We found ourselves in all these conversations around legged robotics and just saw that community continuing to build. We had to figure out why this fellow in Italy was buying 100 of these very small, real tiny motorsport servo valves, and it was because of the quadrupeds he was working on. And then got introduced to Marco Hutter's group at ETH Zurich and have been working together on some of that work that Marco showed, specifically the early work in getting the machines under control, and so that they could become robotic platforms for the research work that's just continued to build. So the company, really quickly, it's basically a $3 billion mechatronics company. We end up in these kind of higher consequence of failure motion control applications on all these different domains. And so we do flight controls for airplanes, simulation, motion bases for flight simulators, construction equipment, industrial automation, machine tools, injection molding machine. Usually there's some element of performance and a bit of tailoring that takes place into the applications. We have medical work that we do, got quite a bit of pedigree in the space domain, subsea, so all these different areas. We have locations around the globe. The founder liked to travel, so we ended up with a number of connections. We have a presence, a number of sites over here in Europe. And so the company itself, it kind of grew up in this fly-by-wire world. The start of the company was in the 50s. So we kind of grew up with fly-by-wire. We started around the 50s when guided missile technology was kind of in the analog state. You had to have these very precise transducers that turned the milliamps of electrical current into controlled hydraulic horsepower. But that's just become more integrated, more complex, more software centric, and in the middle of where digital integrations and doing that safely became a key theme. So that's kind of the background or the mindset of the company as we think about the opportunities and why are we sitting here talking about construction today. We had in all those different areas, we had innovation activities going on. You can see the picture to the right, our three themes around digitization, electrification, and robotics and autonomy. Those things are happening broadly as far as we're concerned across all these different domains. And actually construction and mobile machinery isn't historically an area that we have a lot of presence in, but we could see all the activities going on from our involvement in the community here. We could see things progressing, felt like what was possible was exploding rapidly. And so we thought we'd better figure out how we might participate in that. Is the idea of a mechatronics company in robotics and autonomy. We've been in that area for decades, but it feels different somehow. And we have this picture of automation outside the factory. So the idea that you're automating, we've seen the productivity improvements that have happened inside the factory, on the factory floor. If you look at a modern day automotive factory assembly line versus one in the 40s or 50s, it's very different. That same thing hasn't happened in some of these other harder to get to domains, but we think that the convergence of technologies and enablers is kind of making that point of enabling new ways to solve these problems that globally the world has around productivity and sustainability. So we started this off-highway group, and it's been doing kind of two different thrusts. It's had an electrification thrust. We've been working with a number of OEMs, basically leveraging the technologies, the cost reductions, and the practicalities of electric vehicles in the automotive space. You think about, well, where else is that a problem? Where else is sustainability also a challenge? And so that's been an area we have a background in high power electrics that's lent itself into those activities. But in the back of our mind, we know when we convert these machines over to electric, in general, they're entirely closed loop controlled machines. They're kind of going from open loop diesel hydraulic machines to fully controllable robotic platforms. That's how we look at these things. It's like these are robots, and all the things that are happening here at ICRA and are all kind of enablers. We'll work on trying to establish, controllable, safe platforms to leverage that. I mentioned the research work that we've done with the ETH folks in Zurich. That's been a great learning journey for us. We did some early automation work in the agriculture space that also has productivity challenges and similarities and differences in domain between the construction domain and the agriculture domain. But did some early work there, thought there were opportunities there, but we felt more pull coming out of the construction domain. And so we've been spending most of our efforts in that area, focusing on automation use cases, the idea of working directly with construction end users. They're the problem owners, understanding what their problems are and how these tools might be useful to actually solve problems in new and different ways. And so to the right, I'll actually talk more about, this has been an area that we've been deploying for the past couple of years to just gain that experience. And so it's been material handling automation in industrial scale, utility scale solar sites. So the idea that we're trying to move the world off of fossil fuels, renewable energy, solar is a great opportunity space. The cost per kilowatt has actually come down below that of fossil fuel, but it's to scale it, it's a lot of work. You're basically building 1 million part erector sets out in large fields. And so the idea of applying automation to what is a fairly repetitive task, it definitely has its challenges getting labor. It's in remote sites. In general, the sites are kind of live for a duration of maybe 9 months from start to actually hopefully getting the field commissioned, and then you're on to the next site. And so it is a great automation opportunity. We've been focused on the kind of first start of that is actually feeding the work crews, the idea of a continuous workflow or a kind of lean mindset of continually feeding that material to the crews so they can remain productive. And I'll see if I can get this video here showing the repetitive nature of it. So it's an automated robot that is picking up these pallets from the laydown yards, delivering them to the work crews. And you can see the repetitive nature, installing those panels over and over again. And then taking the garbage, the pallets back to the laydown yard. That's kind of part of the process that's automated. And then that's been a fairly successful deployment. It's had us have to think through how to do this safely. You can see how close the work crews are. They operate, the machine is part of the work crews team, essentially. And when they do this, normally there'd be an operator in cab, and that covers a lot of the safety aspects. When we take that operator out of the cab, it's just a different, there's a lot of differences that have to be taken into account, but we feel like it's a great opportunity. And then it does lead to some of the more manipulation intensive tasks. One of the first questions we get asked is, can you help these poor guys that are, constantly lifting the panels and placing them repetitively? There's a lot of strain on them. In general, the panels, to become more productive, the panels keep getting bigger and heavier. So a lot of interesting problems to solve, but it really got us thinking about the safety of that and the idea of how in this domain are we going to do this safely. So we're kind of drawing on our industrial and various regulated industries background to think through, well, how are you going to do this safely? So the idea that safety standards exist, it is, in general, construction there's a safety culture that exists in the industry. It's there for good reason. It can be a hazardous environment. And so really the key is to kind of fit within that. And there already are, there are inside factory or industrial automation standards that have long been established. The machinery directive here in Europe is an excellent example. It's establishing the essential or the bare, that what you need to be considering for health and safety requirements as it applies to machinery. They realize that safety, more and more, it becomes integrated with the systems. A lot more, we're relying on electronic controls, sensors to do that. There are methodologies to do that safely. And so the IEC 61508 is kind of the industry standard for safe automation within these machine industries. And then how to do risk assessments, that's a key. I'll talk about that in a couple of minutes, but how to do the risk assessments to figure out how hazardous is this? How do I need to mitigate those hazards and keep everything safe? Those are established, but in general, the frameworks are sufficient for what we're trying to do here, but we have to think about the differences. Back to, we're taking the operator out of the cab. It's amazing how much is kind of grown up with that mindset in place and just assumes it to be, but now we're going to change that. And so in general, the hazards and mitigations need to be adapted to the technologies. And so we have new threats, hazards. These are almost always connected platforms. And so if you're not thinking about cybersecurity, that's going to be a problem. It's the way of showing compliance. We have new tools. The fact that these are connected platforms opens up new opportunities. So we really, I guess the point is, we're doing the same thing, but we have to change our approach, to adapt with the tremendous capabilities that are coming online. And in general, bodies that are here in Europe tend to be on the more progressive side in that enabling automation. And so we find it's excellent to be participating in those communities, trying to understand that. The historical standards, the way they're written, mostly think about the environment of the machine, the operator in the machine. And the gap that there is in general as we introduce these new technologies is this notion that the advances in perception, complex software intensive systems leave a gap in what needs to be covered, the processes you use to kind of assess risks, the processes to establish the compliance. And so that's really, it's taking into account the domain that this machine now is part of a bigger system, and that tends to, every domain has, you have to respect the domains that you're operating in. They all have their particulars. From a safety point of view, probably maybe 75% of it is common intent, right? You're trying to prevent harm to humans, harm to property, but inevitably the domain factors in and how you need to show compliance. And so what you see is these evolution of standards and working groups that have been and this is all, work that's been in progress for, I would say at least six plus years. It's really kind of taken along with as you guys have opened up the opportunities, the community's trying to figure out on the standard side, how do we introduce that safely? And so you can see in all these different directions, it's kind of like a hub and spoke kind of diagram. You can see we have specifics in earth moving machinery, ISO 17757, which flows down to the machine level 19014. Same thing for agriculture, mining, industrial robots, automotive, railway. All these regulated industries are thinking about the implications and how can we actually have this as an enabling tool to solve our problems better. But it requires you to have a system kind of mindset. You actually saw them in Mark Railbird's presentation yesterday, or a keynote, where he mentioned we have to start thinking more about system integration, system engineering. There are aspects of that we're going to need, and mainly the main one is that idea of thinking about the domain of your system, what the span of it is, and then safety in the end is a risk management process, figuring out how to do risk managed technology insertion, managing that risk over the life cycle of the product or service. And so that idea of thinking through the risk management approach of I'm going to understand, I'm going to plan out what I think I'm going to do, what the extents of my systems are, what those hazards are, the analysis that supports the risks, assessing the risks, and then making decisions off of it in a repetitive loop. But you start out at kind of the lowest level of this collection of control systems is then built up into a vehicle system. Well, it doesn't stop there. It also includes the operating zone that you're operating in, and that's where the domain really comes in. And so thinking up what the operational environment looks like, things like what are the environment? Is it a controlled, contained environment? Is access to it limited? What are the existing regulations that you have to fit within? What's the state of training for those people that are in it? If it is a contained, controlled access environment, what level of training do those folks have? What sort of markings, signals, signage? And so those are just examples, but it's really thinking through the entire machine human environment as a system is kind of part of the mindset, and then planning around it at that level. And then from there, sorry, I keep hitting the wrong computer. I'm going through and then doing the risk assessments. And the reason to do this risk assessment is really to understand how am I mitigating these hazards. I have basically two main knobs to turn within that. I have this path. If you look at the diagram to the left, there's something called ConOps, or the concept of operations. That's how am I going to use this equipment? What tasks am I going to use it in? What's the environment that I'm using it in? And then I've kind of got the product integrity level of it. And I put those two together. What safety is inherent in the design or is not inherent, or what hazards are in the design. And then taking an operational assessment, risk assessment point of view on it to then figure out, is my risk acceptable or not? And that depends on environment, and it's very much, that's on a society driven sort of element. What's considered acceptable? There's no such thing as zero risk. It's all a matter of what's tolerable, and it depends on a number of societal factors. But it's really those two things I can do as I think about if the risk is unacceptable, I can either further constrain my environment, or if I've got a very unconstrained environment, it's going to put a lot more requirement on my product integrity and how I have to safeguard. And so that's really what the kind of the flow to the right here is. So I'm like, the little picture there is like, if I'm doing this on a Roomba, the consequence of failure is fairly well defined. There's maybe a few hazards around, I might start a fire, or I might, what are the things that might pose hazards, but very different than if I'm controlling a Cat D9 on a construction site that's got people on it. Just thinking through what those are. And so it basically kind of flows into a severity. What's the severity or consequence of if something goes wrong? And then what's the probability of that occurring? You don't want to be, if it's almost never going to occur, that's different than something that's highly likely to occur. So that's really what the point of this diagram to the right, that's right out of ISO 13849, the idea of starting with the severity of the injury, of whatever my hazard is when I identify it. What's the exposure time if I expose constantly to this risk, or is it only a very small portion? That does matter in terms of overall exposure. And then what's the possibility to avoid that hazard? So it's kind of a very prescriptive process in this standard to get to what's the in the end, the performance level requirement. It's kind of the how much rigor do I have to put into these safeguards? It's tied to that severity probability sort of matrix. But there's pretty well established processes for doing that. But how to do that with these highly automated tools and these complex integrated systems, that's part of the challenge. And so it drives you to start establishing what is a safety concept. In the end, that's what, as you engage maybe third-party regulators, it depends on the environment, but you're trying to talk with whoever that person is that's on the hook responsible for safety. What's my concept of operations? How am I going to approach safety? And so that idea, we're probably going to be in the state where we're going to be working collaboratively in and around humans for some time. It's, the completely automated work site, you saw it on the right side of Marco's charts there. It's going to take a while to get there. That's not where we start. And so the idea of I got to have a working concept and manage the introduction of these technologies. How am I going to do that? So the basic safe automation principles that are established, the idea of I can extend those. I can think about how I can incorporate these technologies, machine learning, understanding what the hazards are, having much more refined perception of the environment, and the fact that I'm connected to probably some bigger network of information that can help inform me on the safety aspects. Can I somehow take that into account while actually coming through a path that actually I can build up? What I want to do is build up safe hours of operation, and risk managed basically means I want to start with my lower consequence of severity activities, build up hours of objective evidence that I know how to do this, move to my mediums, and eventually to my highs. And so working your way through it, the idea of inevitably, these are always some sort of a layered approach that you're taking. You don't want to have a single point of failure that might result in some catastrophic event. And so the way we've been thinking about it is really the way the industry thinks about it now. If you look at how they, I mentioned these are hazardous work sites, there's already trainings in place for how people and machines interact. And so that little diagram on the bottom there shows training material that is provided to crews on site and the operators when they're working together. And there's whole systems. What's the red zone? Stay out of the red zone. It's most likely where injuries to occur. There's orange zones where probably that person that might be around that machine has a little bit more time to react. That's a little bit of a slippery slope, but and then you've got a yellow zone that's like hey, like at this point, you're starting to approach the machine. What are the processes? And they actually you can see these processes on site where sometimes it's a horn beep between two machines. If it's between a person and an operator, a lot of times there's some sort of a thumbs up acknowledgement. It's like it's got to go in both directions. It's kind of the same. We're just taking the person out of the machine. So how does the machine communicate with the human? How do we figure out how to have interactive plans? And then how do we kind of layer our safety approaches? And so the idea of, all right, if I'm going to layer it, and then ultimately, by the time I get it down to the reactive safety layer, that's kind of my last chance, employing some of these advanced technologies that in the end are kind of more black box, very hard to do traditional verification, validation work on. You don't know what's going to come out based on the inputs for all combination of inputs. It's like, all right, we can use those in our yellow and orange layers to inform the integration of the people and the machines. But by the time we get down to the last ditch safety layer, we're going to do that for the time being. And provably safe means we have ways to do that. They tend to be much more limited, but basically use the intelligence to avoid the hazard from happening in the first place. And that last layer of protections there just to make sure, even if you do lose those upper layers, you've still made the work site safe. And then the point of that basic approach from a philosophy point of view, it's already there now, and you're just trying to figure out how to map technologies into it. Is kind of a approach we would expect that to evolve as like everybody grapples with the implications of the technologies, the opportunities. You can see a lot of research work on explainability, understanding the implications of data sets to reliability of models, but that's all work that's got to be done. And so it's probably not, if that's the plan to start there, that's probably going to face a lot of roadblocks and a lot of challenges. And so with that mindset in place, we've been trying to think through, well, how do we implement then this productivity gain that we're looking for? And so that kind of basic safety concept extends to how would you kind of architect a solution? The idea that you have an inner core yellow safety layer that's like as I mentioned, is there just kind of as a last case catch to stop safe. And I have that at a highly provable, high integrity level. And then I've got all my higher level functionality, kind of my, you could think of the yellow as your sort of reflexes, right? That kind of keep you from doing something to harm yourself. And then the gray areas are sort of your higher cognitive layers. The idea of most of my functionality is going to occur there. I want to have as much of it up in that area as I possibly can. The burden of proving the yellow areas is significantly higher. We usually use if we think of the work that goes into proving something safe, it goes up by a factor of 10 for these yellow related items. Versus the gray areas that are shown in the diagram. And so the idea of segregating system to kind of minimize the footprint to just what's needed, and then coming up with it and mixing it into your operation effort. It's the mindset we're kind of working through to figure out how to do this safely on site, because we want to see those productivity gains. We want to see the future get here sooner. And then the last slide, I wanted to make sure we talked and thought about cybersecurity as part of that. We have a kind of core phrase that, there is no safety without security. All your plans that you put in place to make things safe are jeopardized if you now have an IP address on your machine, as you so often do. You've got a whole new threat vector and ways to kind of undo all that careful work you did to try and make things safe. And that can go down to driving your hardware decisions, what resources that you have to have in place, how you provision a new machine and prove authenticity of the operators, the machines. Like how do you know that everybody on the network is supposed to be on the network? And how do you know one of the tenets is that you've got to be able to identify threats and update those machines in the field to mitigate those threats? So very much an IoT kind of problem statement. There's a lot of thinking. That's actually a diagram from Microsoft on their 7 core tenets for connected machines. They apply to us in this domain just as much, thinking of these as connected machines, because that diagram at the top shows, the old world of you had a product and it was some piece of equipment. You made it electronically controlled, you made it a smart machine. Then you inevitably connected it off the machine, and all of a sudden you found yourself part of a bigger ecosystem. That's where the productivity opportunities are, but it's also creating changes that have to be taken into account when you think about how to do this safely. And it's just the right thing to do. Like all of this is, in the end, safety is sort of a mindset and a culture, but you definitely want to, in construction, respect that. It's important. And then so is people's privacy and right to protect their data. So you have to do your work to make sure you're doing your part. So I think I'll stop there on time, and I don't know if we have any questions.
Thanks for the talk. I just had a little bit of a thought that, so obviously we have to make these machines and stuff safe on site, but do you think the way to make these things provably safe is to rely on structured environments in these sorts of work sites to make the response of the machine and the system consistent and provably safe?
Yeah. The environment definitely has got an important role to play. It's a sliding scale. What you end up with is the more you constrain that environment, the more productivity improvements you shut yourself off from, and the number of sites you can access. And you can watch the self-driving car world kind of deal with this, right? It's like, if I have a completely unstructured environment, kid can chase ball in front of car. It's all right. Well, then if I can't handle that, then I've lost like 80% of the driving space or whatever that is. It's a trade-off. And so, and if you can think of where automation's already gotten a strong foothold, it's been in those more structured environments. And so the poster children, right, are mining has been in place for a couple of decades now, very structured environment with a lot of trained workforce and a lot of hazards. But another great example is the warehouse automation. And so those are pretty constrained environments, and we can do things we have enough control over it to make it safe. But I think the whole point of it is we want to keep going. And so I think it's like they both have to fit together. But I think if you start with that mindset, it then says, all right, well, I want to start loosening it up. I just don't want to go way over here. I want to find where those next productivity improvement opportunities are to kind of help you figure out where should I go next? It's sort of a roadmap approach.
Thank you.
Sure.
I think on the previous slide, you had this center block of safety critical, it was in yellow, if I can remember correctly.
Yep.
Speaking to maybe a lot of the researchers that are here, how do you think that researchers who are working with non-safety certified sensors, or they're working with research grade code, like, should they be targeting these blocks around the boundary, and you might think that the center is for the professionals? Maybe?
Yeah, right. I think I understand what you're saying. It's the same way we've been dealing with it. Right now, we're able to over constrain our environments, and that's perfectly fine. In general, it puts the burden on, hey, make sure there's already somebody there watching the machine if it is hazardous, and you've got a very safe way to stop it. In general, if you're using your phone as your e-stop to stop the machine, that might not be the best solution. You want a very high integrity way to stop it. So it's just kind of stripping it down to what's the minimum to keep me and my pretty trained hopefully work crew that's working with me safe. You want to have a safety first mindset, but there's ways to, doesn't mean you have to fully implement a solution. But back to the idea that of the previous slide, you can control the environment. So some of it is, if it is hazardous, then training the people that are actually dealing with it, finding the minimum pieces that are needed. And for us, that's turned into mostly focused on ability to stop the machine's safe speed, to make sure that something, basically thinking, well, what are the worst things that can happen and how do I avoid creating a hazardous solution? It gets to a pretty short list if you're very, working closely with the environment, and so it is. But if you are working your way into more hazardous areas, it is worth at least thinking, actually having a little bit of a process to think through before I power something up. Like, is this hazardous? What are the hazards? What do I need to do to mitigate those? It's inevitably, that's how this thing starts taking shape, is you have a process. Safety is not so much a design as a process. You kind of integrate into the work that you're doing, but what to do depends on the hazards. And back to, if it's something that's not really going to harm anybody, then you've got a lot more options. If it's getting more hazardous, you probably need to pay more attention to it. Kind of a it depends answer.
Hello. Can you go back to the material handling automation slide? Yeah.
Yep. Highway.
Yeah, this one. So can you discuss a little more about the research challenge in such kind of scenario? You mentioned it's unstructured, or what kind of research challenge you think to make such kind of scenario automation? Because a lot of person or other machines or what? So can you highlight a little more? Yeah.
I'm sorry, I missed the
what's the research challenge?
The research trend?
Challenge or difficulty?
Oh, challenges.
Yeah.
Okay. It's the progression of more and more automation is one of them. It is a constrained environment in that it's in the structured scale. It's probably on the more structured side of things. It does change over time, but how it's going to change. There's generally a plan, and so how the site's going to unfold. But in general, like a lot of these things, just automating one task is kind of limited value to the person that's actually got to solve the problem. They look at the size of their work crew and like how many, how much, what their problems are, access to labor, injuries, productivity of those crews. How do you improve that? And so you really end up, it draws you into more of the ecosystem that's needed to make that crew more productive. And so that's why, the research trends drive us towards more manipulation sort of tasks, kind of similar to other discussions this morning. We're starting with kind of basically safe navigation and ability to just pick up a fairly well-defined payload and deliver it to its destination, which in the end is a moving work crew. So there's some localization in there, but it's really the more manipulation tasks that humans are, those hard ones, right? I think that was another Mark Raver of like, that's where we're going next is, the panel installation. There's a number of the work crew there are tied to handling panels, installing. There's some pre-work to map out the site. That one's pretty, that's already fairly automated, but it's these more manipulation related tasks that are harder to reach ones. So I think that's where, the research is really going to, benefit.
All right. Sounds
Okay.
good.
All right.
Thank
Very
you so
good.
much for
Thank
your
you, everyone.
presentation.